These are the notes on plate tectonics, continental drift, and landforms, and then it will also be the plate movement notes, both put together. The Earth's layers. The Earth's inner core is solid, it's made of iron, and it's made of nickel. It'll become very important for you guys to know all of the different layers and what they're made of, too. Working from the inside out of the Earth, you've got the inner core, and then you have the outer core. This is liquid, and it's molten rock, kind of like magma. And then the mantle, which is where convection occurs. If you've ever watched the lava lamp that I have in the classroom, there's a light at the bottom, which is the heat source, which heats up the bubbles and makes them rise. We talked about the concept of density, and that's where all of this will come together when we talk about convection. When things become heated, they become less dense, so they're going to rise to the surface. And then when they cool, they get more dense, so then they sink to the bottom, and then it's basically just a circular current of heating and cooling, and therefore rising and sinking. And the mantle has two different parts to it. The asthenosphere, which is a warm plastic sort of like layer. Asthenos means below or beneath. So the asthenosphere is below us, basically. And then the lithosphere is partially molten rock. Lithos means rock. So the lithosphere is made of rock. Earth's layers, still the crust. This is where we live. It's relatively cold and brittle, which means easy to break. And there are two different types of Earth's crust, and these two types are very important to the entire unit, so make sure you know the two types of crust. Oceanic crust is made of basalt, and the oceanic crust is very thin. So if you think about going down to the very bottom of the ocean, you have this very thin layer of crust before you get down into the mantle, which is where all of the magma is. And then the continental crust. We live on the continental crust. The continental part's the land, and it's made of granite, and it is a thicker layer. And then with continental drift, the clues that we have about that the continents used to be all stuck together in one big landmass, that was called Pangea. Pangea means all lands. So when they were all stuck together, that was Pangea. And then obviously they've separated from that one big landmass now, and the things that we know about that. Fossil clues, climate clues, and rock clues, and they all sort of match up as to how we think that the whole, all of the continents fit together all at once. And different plate boundaries. Had a divergent plate boundary. Divergent sounds like divide, and when you divide a number, you pull it apart, you make it smaller. So at divergent plate boundaries, the two plates are separating, and the example would be the Mid-Atlantic Ridge. Down the middle of the Atlantic Ocean is a ridge, and those two plates, like the plate that we live on and then the plate where Europe is, are pulling apart from each other, and when those two pull apart, magma can come up to the surface, and then it hardens into a ridge. At a convergent boundary, if you ever taken Spanish, con means with. So at a convergent boundary, these two plates are coming together, and when two plates press on each other, you're going to make things like mountains. At the Himalaya boundary, at the top of India, India is pressing up into the rest of Asia, and that's where Mount Everest is, and those mountains are actually still continuing to grow. And that's also how the Appalachian Mountains got formed right here near us. The North American plate got pressed on and pushed up to make these mountains. And then at a transform boundary, this means that you have two plates and they're moving side by side next to each other, kind of like a pair of scissors. You have one that's moving one way and the other one's moving the other way. and they make a transform boundary. And the example would be the San Andreas Fault. That's off on the west coast of California, where Baja California is, that little piece that falls down into Mexico. It's sort of thought that that little area might fall off and become part of just an ocean, or down into just sort of fall off, maybe become its own island because of this transform boundary and the way it keeps shifting. And then with plate tectonics, they can either be constructive or destructive. They're either going to build new crust, like we talked about when the plates pull apart, magma comes up and solidifies and makes new crust, or you're going to destroy crust. When you've got two plates pressing on each other, one of them's going to lose and one of them's going to get pressed down underneath and turn back into magma and be melted. And then with mountain building, we already talked about when you make mountains, you're kind of crinkling up the crust. You're folding the crust at convergence zones where things are being pressed together. You're going to push up the land, and that makes horizontal pressure. So, like if you press your two hands together and then you squash them. And then they're also going to make wave patterns that you can tell in the mountains. And then you can also have faulting. There are two types of faulting. You can have tilted, which means you have one fault and one scarp. We'll talk about the definitions of those words in a minute. And then lifted means two faults, two scarps. And then you have vertical pressure that way. So you've got one thing going up and the other thing going down instead of two pressing on each other horizontally. And then the definitions: a fault means a break in the crust. A scarp means exposed earth at a fault. So if you think about, we just talked about vertical motion, one plate's going to move up to expose part of it. That would be the scarp. And then at the fault, that's the break between the two. And then moving into the plate movement notes, the three types of boundaries and movement. This is a map of all of the different plates on the whole world, the whole Earth. It's oriented a little bit differently. The United States is right here in the middle. So we're living right here, sort of where the sea is for the Caribbean plate, which is down here. So the whole North American plate is pretty huge. So we're pretty steady here, right in the middle of it. And then you can see all the other plates around us. Plates move because of convection. You heard me talk a little bit about this circular movement, but we hadn't talked too much about it. At the very inner core, it's hot. So you've got heat that sort of radiates out from the inside to the outside, to the crust where we live on. And if you've got the heat here, when the magma in the mantle heats up, it's going to rise, because we've talked about density. When something gets heated up, it gets less dense. So it's going to rise to the surface. And then at the surface, it's cooler. So the magma cools down, and then when it cools down, it's going to sink until it gets back closer to the inner core where it heats up and rises again. So it's just a circle. It's a cycle. It's called convection. And like I said, with the lava lamp in the classroom, take a look at it when you come back into class. We can talk about it a little bit. Now, three different boundary types: a divergent boundary, convergent boundary, and transform. Remember, with divergent, you're pulling apart, you're dividing them, you're making them smaller. At a convergent boundary, they're coming together. And then at a transform boundary, they're moving side by side. Or one's moving away from the other one, but next to each other. Seafloor spreading. In this diagram, it shows you a mid-Atlantic ridge, mid-ocean ridge, where the magma comes up because these two plates are moving apart from each other. And at this ridge, when the magma comes up and solidifies because of the cool water above it, it solidifies in the new crust the current polarity of the North Pole and the South Pole. Basically what happens over thousands and thousands of years is that the poles reverse, and like the North Pole is no longer oriented as north, it's oriented as south. And like I said, this happens over thousands and thousands of years. Currently we're under normal magnetic polarity, but it does change. back and forth, and if you run a magnet across the surface of the ocean floor, you can see how they've been reversed back and forth over the years. And then an example of a divergent boundary is a rift valley. This is the version of what happens on land. You get land that separates away from each other, and that's what's going on here near the Red Sea and the Gulf of Aden, near the Arabian Peninsula. That's what's happening right through here. And then some divergent facts. The plates move apart. Remember, divide, you pull apart. The force is tensional. If you think about a rubber band, when you pull on a rubber band, the rubber band gets more tension in it. And then the result of the motion is going to be constructive. It's building new crust as the plates pull apart because that magma comes up and solidifies and makes new crust. And then some examples, seafloor spreading. We talked about the Mid-Atlantic Ridge, and a rift valley is what happens on land. That's the Great African Rift Valley, which we just saw in the diagram a minute ago. And then a key term that goes along with all of this that you definitely have to know is a subduction zone. It means where one plate moves underneath of another one. If you have two plates coming together, one of them is going to be able to stay on top and one's going to have to go underneath. And when the one plate goes underneath, it's going to get melted and turn back into magma, and this is a subduction zone. And again, it happens at convergent boundaries. So if you have one oceanic plate and another oceanic plate and they're pressing into each other, one of them is going to lose and have to go underneath of the other one. So the subduction zone is what's going on right here, because that land is going underneath and it's going to get melted back into magma. And then you can also have it happen when you have an ocean here and a continent here. They're pressing into each other. The oceanic plate is more dense, so it's the one that loses and has to go underneath because it's heavier, so it sinks easier. And then when this oceanic plate presses into the continental plate, it pushes up the land on the continents and makes mountains, and you get a volcanic arc on the edge of the continent. This happens on the edge of the South American coast where the Andes Mountains are. That's what happened there. And then if you have two continental plates coming together, we already talked about this is what's going on with the Himalayas. You're going to be building up crust, making new mountains or higher mountains on the plate that gets to stay above. And then some convergent facts. Convergent means to come together, and the force is compressional. If you think about sticking a piece of Play-Doh between your hands and you squash the piece of Play-Doh together. The result of the motion is going to be destructive because old crust is destroyed, getting pushed underneath of the crust that gets to stay on top, and then it gets destroyed by being melted back into magma. And then it can be constructive because you get to form mountains for that land that gets pressed up. And then some examples, if you have ocean-to-ocean boundary, that's like the Aleutian Islands up in Alaska, that tail that comes off of the main part of Alaska. The ocean-to-continent, we already talked about the west coast of South America where the Andes Mountains are. And then continent-to-continent, that's the Himalayas and the Appalachian Mountains. And then a question here to think about. When a continental plate collides with an oceanic plate, why doesn't the continental plate subduct? Why is the land plate the one that stays above? And I sort of already gave you the answer. It's because the oceanic plate, which is basalt, we never actually saw that when we did rocks, but basalt is a dark igneous colored rock. It's more dense. It's heavier than the continental plate, which is granite, and granite is a less dense igneous rock. So the word here that they've used is heavier, but we know that we can use the word dense. Basalt is more dense, so if it's more dense, it's going to sink to the bottom. Think about that concept of density that we've been talking about all year long. Here's a picture of a transform boundary. Here's the San Andreas Fault right here, and I talked about the little tip. Here's where Los Angeles is, and then this is Baja, Mexico down here. And the way this is moving is that here in the Pacific Ocean, the plate's moving up, and the North American plate is moving down, And some people are a little bit afraid that this little tiny bit of land is going to fall off into the ocean. So, like people that live in LA, they're not going to fare too well. And some transform facts. The definition is that plates move side to side. Like I said, one moves up, one moves down. The result of the motion is it's not destructive or constructive at all. And the force is what's called shearing. I said, think about a pair of scissors. You've got one piece that moves up while one piece moves down. Shears, some people call scissors shears. And then an example we already saw is the San Andreas Fault, and that's the best known example. And then to talk about hot spots. Volcanoes are formed when plates move over a weak spot in the crust. And this occurs in the ocean, like places like Hawaii, and then on the land, which is Yellowstone. And we'll talk a little bit about what's called a super volcano when we get to talking about volcanoes, but that's what we think is going to happen in Yellowstone. This weak spot in the crust, the magma is able to force its way up, and then that's what forms things like Hawaii. And then here's a little example. It shows you this specific plate is moving up kind of towards 10 o'clock here. And this weak spot in the crust, the magma was able to force its way up, and it made this island back here a long time ago. That's the oldest island. And then as the plate continued to move, it would make a new island. And then it would move and make a new island, and move and make a new island. And it's currently working on, I think, the 7th Hawaiian island right now. So eventually, in thousands of years, we could get an 8th island. And then another question to think about. What process causes the plate to move over the weak spot? And hopefully you know the answer by what we've already talked about. It's convection. Remember how we talked about that circular current, the rising and falling of the magma in the earth based on the heating? When things get hot, they're going to rise. When they cool, they're going to sink, and it's that circular current that happens in the mantle. And then here's one more picture to sort of summarize everything we've talked about. Just take a look at the different plate boundaries here. We've got a convergent zone. The two areas are pointing towards each other. You've got the mid-ocean ridge here at a divergent boundary. The two are pulling away from each other. A little hot spot, that weak place where the magma can pop up and make a little island. And then you've got some mountains happening here because two plates are coming in, pushing on each other. And then a subduction zone, one plate's going down below the other. Little volcanic island arc, or not an island arc, but just volcanic island, or volcanic arc over there. All kinds of different things going on here. It's a very good summary of everything we've talked about, so make sure you understand that when we get back to class.